in the webinar series. My name is Bente Lilja Bye. I'm going to be your host and also introduce you to Iliad. But before I do that, I want to do some housekeeping. Please keep your microphone off when you're not speaking. And we will ask questions, we will answer questions and have the discussion towards the end. So be patient, do ask questions and comment, please, in the chat. So we welcome your engagement all the time, but we will have the discussion at the end of this webinar. During the webinar and during the presentations, you will be given a few very simple polls, and we will show you the results of these polls. So we will be very happy if you are contributing to these polls. We want to create an atmosphere where we have a lively discussion and free sharing of information and perspectives. In this case, in this webinar, we are going to talk about ports and activities in ports. And we have a few, actually, 3 digital twins answering or discussing port activities. And they will be presented by those who have requested these services and those who have developed these services. So this is super interesting. We also have a few perspectives from organizations and of ports, and I hope that you all will be chipping in on this if you are representing a port or somebody who is delivering some services to ports. Please do participate in the discussion, even first in the chat and then afterwards in the discussion. So with that, I think I will start to show you the program in more detail, so you are a little bit prepared on that. And then we will introduce the speakers to you as they are appearing in the program. So first, now, bear with me, I will share the screen. Like this. And then I will do this. So, as I said, we are going to introduce you to Iliad first. Then immediately we will see the first digital twin addressing risk assessment environment for maritime traffic managers. And that will be Captain Milen Todorov doing that from Varna Port. And then we have a digital twin on blind navigation, and that will be Captain Andrey Stanev from NAVIBULGAR, also in the Varna port. And then some theory, overall architecture of the Varna Bay digital twin and technological aspect by Todor Ganchev. And then we have yet another twin from another place, from Valencia, a digital strategy for ballast water management, tackling invasive species at the port of Valencia. And we have 2 speakers there, Aida, Mora, Ayuso, and Brandon Onuoha from Fundación Valenciaport. And apologies for the pronunciations. Now, unfortunately, originally we would have also a presentation from the port of Oslo. Unfortunately, Hege Thurman, she got the flu and had to, pass this opportunity, but I'm sure she will be happy to see the presentations afterwards. Then we have International Association for Cities and Ports with us, and Noemi, Mene, she will introduce us to the organization and how they are working on digital twins. And then we will have a discussion. The webinar is planned to be approximately 1.5 hours. So we hope you can stay with us. Just a few more words about me, other than my name. So I'm the innovation manager, among others, in the Iliad project. But I run a research and consultancy company that are addressing generally the use of Earth observations in practical use in services and applications. And I have been working on this for a long, long time. I started to work on this as a research director at the Mapping Authority of Norway. And then we have with us also Sophia. You have all our excellent innovation detective, I would say, Sophia Parzadanyan. She works at the American University of Armenia, and she has an extensive experience with business intelligence, particularly to help innovation processes and companies. And she is also working in Iliad on the Blue Tech support service that we are developing for the various digital twins. So we are the ones who you have learned to know during the process of planning this. This is for our eminent speakers, and for the audience. Now you know who we are. So a few words on digital twin, Iliad and digital twin. There are many different definitions of digital twins. I'm just informing you of that. But for Iliad, we have been using this definition that digital twins that we are providing, the digital twin of the oceans in Iliad, we provide a virtual environment representing the ocean that is capable of running complex predictive management scenarios. And this innovative system integrates across many different disciplines using lots of different sensors, ranging from the space to deep in the ocean, and building also on various models and digital infrastructures. And we are doing this in an interoperable way that is using a lot of data, so data intensive and cost effective, because this is an innovation action and we want the solutions to be sustainable, and the cost effectiveness is one of the keys to succeed with that. So that's a short introduction to what how we see digital twins. Oops, let me see, I'm going on. That was a little bit too much. Yes, we are developing a series of twins, actually, the thematic twins, and located in various places. So here you see the 12 different thematic areas that we have defined. So we have jellyfish swarm forecasting, we have oil spill, plastic pollution, fisheries and aquaculture, marine and maritime insurance, aquaculture and water quality and ship traffic. We have also coastal sediment and ocean. Let me see, Hannah. It's very hard to see everything in this computer. So ocean energy potential, the Met ocean hind now and forecast, ballast water monitoring. We have one of those cases here, and harbor safety we are going to discuss today, and also wind energy capabilities. So those are the 12 different areas, and as you can see, there's really a large variety that are using sometimes very specific data sets and solutions, but their Earth observations is common for all of them. This is, there's something funny going on with the, okay, so we have an innovation booster. As I said, we are an innovation action, and we want the solutions that we are developing to be sustained also beyond the project period. And for that, we are really addressing the different parts of innovation process. We are creating a lot of capacity development materials. So we have an academy where we are collecting all of that capacity development activities. We have business activities. We are developing business models, and we have this Blue Tech facility, as I mentioned. Policy is relevant for all of the different twins, both when they are developing the twin, but also we can inform future policy making. And we have a marketplace, because all that we are creating here, we will want you to be able to find both the individual twins and the components that are being used to build them. And we are not only making this marketplace open to those who are developing Iliad twins, but also to the ecosystems around us. So the ecosystem of partners and activities that is necessary to build a digital twin, that is. Iliad is a innovation action project. We represent 18 European, African, and Middle East countries. So we are covering more than Europe. We started in February 2022, and we will finish our program actually this end of July. So we have extended 6 months. The budget is quite large, in total close to 19 million euros. So this is a big country. This is a big consortium. Our 54 partners are representing both academia, businesses, NGOs, industries. So we cover a lot of stakeholders. Now, let's start with the first pilot. So Captain Milen Todorov, I think I made a mistake here, Milen. I apologize.
No problem. It's correct.
Okay, okay.
Don't worry.
Okay. So he has been engaged as an end user in this case here with his extensive experience from ports. He has a technical background. He knows ship management and navigation, and is one of the key players in the port of Varna. The floor is yours, Milen. We are excited to hear what you have to say.
Hello to everyone. Thank you very much for organizing this webinar and letting us share our experience within the project. I will share in few words our participation and the benefits we are having from the Iliad project. So let me share my screen now and just go through several slides. Our company, the Bulgarian Ports Infrastructure Company, is a state-owned company which has, let's say so, the role of landlord for the ports in Bulgaria on behalf of the state, of the government, and is also responsible for providing the infrastructure for access to all the ports in Bulgaria. We are participating in the Iliad project due to the opportunity to test some new technologies and the development of some of our ideas for the technological enhancement of the safety in the port. So we are participating as a partner with a budget of 177,000 euros, more or less. Our role in the project is as a participator and also as an end user of the outcome of what we are developing. So we have developed infrastructure all along the coastline, containing of many meteorological and signal stations, which are able to collect data for the environmental processes in particular points. They're more in the port areas where the traffic is more congested, but we have also such data stations all along the coastline. So during the years, we have collected a database of information about what is most important for our job, of course, the state of the meteorological conditions in the areas where the ship traffic is being regulated by our vessel traffic services, which is also part of our company and our directorate. So we wanted to use this data in order to enhance the meteorological models and to be able to predict the meteorological events, in particular neurologic points where the traffic is very dependent on meteorological conditions, with better resolution in means of area and timing, so to have more accurate forecast for the upcoming events based on the data we have collected during the years. So one of the main projects, pilot projects we are participating in is the Varna Harbor Safety Port pilot, together with the Technical University in Varna, and we are now assessing the outcomes of a modeling and software presentation of the predictions based, the improved predictions based on the data we have provided. And these databases, some of them are already something like 15 years old, so we have collected a lot of data for particular points. For some of the points, we have smaller database, but at least we have some 5 to 10 years perspective everywhere. So we already are able to improve the assessment of the forecast of the meteorological situation. So the software which was developed in the Technical University would give us a more clear picture about what is expected to happen when a vessel is approaching from open sea to a particular area in the port. Here you can see the areas where mainly ships are being berthed. This is Varna Lake, and this here is the bay where the ships are coming from open sea. So if a vessel has to enter a particular area of the port, she has to go through several points where we have meteorological stations, and this would take from 1 to 3 or 4 hours, depending on the place the vessel is going and her speed, of course. So we have here a prediction all along the vessel's route to her berth. And here you can see on this slide what is the prediction in several particular points. In this case, the vessel is going to a shipyard here in the Lake of Varna. So the interface, the presentation is also being well developed. We are satisfied of how it looks and how it works for the time being. Here is a little bit zoomed picture of the same situation. You can see the stations, the data from all the stations along the vessel's path, because we are not using only the historical data in this software, but it also works with live data from all the stations, and in every point the live data is being compared with the heritage model which has been made. So of course, it's an experimental solution so far. So we are trying to assess how it would benefit our work. I could say that somewhat it works because, of course, there are some occasions where the prediction is not correct, but mainly in the most of the cases, if we compare to the official forecast and afterwards to the outcome of the weather conditions, it turns out that this software instrument gives very nice results. And now the question is for the reliability, how often we will have the correct result, but it works in means of modeling and providing the forecast. Here we have a comparison for two periods, same periods into different years. It's maybe it can give some idea how the model has been created. So we are searching for the model in the same periods during the years in the past, because of course these events are very seasonal. They depend also on the time of the day, the time in the month, and so on. And they depend somehow on the moon stages, and so everything is being assessed, and the model is being still developed. And this here you can see, for example, for particular time period, the forecast for the wind speed in this case. The model gives a very good results in more static type of data like temperature and pressure. And for the wind speed and direction, it is still it still gives good results if we speak about the wind field in general, and for the particular areas it would provide a good forecast, but in most cases it's for now a matter of reliability. There are several other projects. One of them, Captain Stanev will give more information about blind navigation, and the other one is for collecting data for meteorological and other events from the society, not necessarily experts in the area, but these are connected with our developments because they share information and use information interoperably. For example, the blind navigation could benefit of the improved forecast conditions. And we also have cooperation with the university in Tallinn for installing a few sensors for current and also for level. Now the level part works pretty well with all of them. We are adjusting the currents, and this is in general the slides I have prepared and the information, but I could also show you how the software works in real life conditions. So this is the interface. We can change the layout of the maps depending on how we prefer to see the situation. Here are the approaches to Port of Varna. We can find the ship in the area who is about to enter the port. There are several. Also, the software calculates the allowed meteorological condition when a vessel could berth or unberth or make any other navigational activity, any maneuver, depending on the size of the ship, her abilities with bow thrusters, rudders, and so on, and of course the port regulations. We could at a period when the vessel is, in this case, let's say inbound, when she's crossing the entrance of the port, and let's choose an area where the vessel, the area is being colored, where is the final destination of the ship. If we choose another area, it will recalculate. For example, here is Varna West, and so on. So let's see if we are going to some of the parts of the port where we have a lot of traffic too. This is one of the shipyards, but let's see about this one. And then we will have the predictions the software makes for every station on the vessel's way from open sea to the place where she's going to be berthed. And you can see here the predicted state of the wind. For example, we have chosen to predict the wind in this case because it's on default. It's set on default because it's more important for our work. And here are the stations around which the vessel passes on her path to her birthplace. And okay, this is more or less how it works. We have, of course, several additional options. We could make a prediction based on some past period. We could choose what part of the database to have in order to use it for prediction of a particular event. And here, let's see, let's make a prediction of the temperature, how it has been. And here we could make also a prediction for a period, but we have to put some period here. And let's say, and here we have a forecast of the temperature. It's based on the model, but it's obvious that because it's already afternoon and the temperature is about to fall, this is more or less obvious. But this graphic is based on previous periods, like compared to how it has happened during this month, during the years back in time. So I hope that this gives some idea, some general perspective, what is our main interest in this project and what we are working on. And if there are any questions, I would be glad to give more information and to answer any.
Yeah, thank you so much, Milen. It looks it looks very interesting and useful, actually, that you have developed this tool. So I'm just repeating that you can use the chat to ask questions to Milen, and we will pick up those questions when we have the discussion later on. So moving on to the next. Thank you, Milen. Moving on to the next speaker, which will be then, I was doing apologies for me being a little bit clumsy. And normally I have two screens in my defense, and now I only have one. So Milen, I want to introduce Milen to you, and he is going to speak about navigation. So Andrey is one of the a very experienced mariner and running boats, big vessels over 3,000 tons. And he has also experience in using various simulators to actually do concrete work out at sea. So, and he is also a technical lead for this particular navigation digital twin. With that, Andrey, I will give you the floor so we can hear what you have to say. Thank you.
Thank you, Bente, for this nice introduction. So once again, my name is Andrey Stanev, and I'm a captain over 3,000 tons. In this particular case, I was working as team leader, technical team leader in technical university. I want to use that webinar to thank the whole team and the whole adjacent team of Captain Todorov. So we demonstrated how what kind of nice work we can do as one united team when we have defined problem in a harbor. So this is a typical problem not only for this harbor but for all over the world, I can say, because the mist is typical everywhere in the world, but in south part of the globe, we have, for example, sandstorms where we have same problem. So I will show you the whole presentation. My presentation will be based more or less more on animations, more on demonstration of how the whole process during development was, the whole team during the work. And on the end, I will show you one quick movie how we did it, the actual tests of the system. So first, I will show you the movie. I believe you all see the movie.
Yes, yes,
Okay.
we do. Can you get rid of the little note, say, you know, at the bottom of your screen? Can you click on hide there? Thank you.
Okay. So like I said, we have two major problems in the harbor of Varna. This animation shows how the thick mist can hamper the visibility on the bridge and the vessel. Of course, each vessel has different units on board, but also what Captain Todorov very well demonstrated is the problem with different wind conditions or weather conditions in different sectors of the port. So, for example, in sector number 2, the wind and the weather condition can be completely different from the sector number 1 or number 5, which is 25 kilometers away inshore. So having in mind those two problems, we started to creating the approach. So one approach is for the thick mist. So when the vessel is inside of the thick mist and the visibility is below the normal condition. Together with the onboard equipment, which is typical for every vessel, like electronic charts, like radar, and other systems, we wanted to put state-of-the-art technologies like augmented reality in place, which will help the team on the bridge to clean the outside thick mist and to see augmented reality based on very accurate photogrammetrical pictures. We did it, which we transform into 3D environment. And so the captain and the pilot and the whole team on the bridge, they see what they see normally without the mist. Now the animation will show you the whole process we passed till we stepped on the real ship to test the system. So in the technical university, we have one of the most advanced simulators. And the best situation is to test the system we created inside of the simulator, where we can create different scenarios, different situations for the ship, and put our captains into these scenarios in safe environment, in safe condition. Because even we do something wrong, it's not a problem because we are in the simulator. So on the picture left side down, you can see what the captain sees on the glasses, augmented reality. The black side of the picture is seen in the glasses as transparent. So only on the computer you can see black, but in reality you see transparent. And so you see your vessel ahead of you, like it is in reality, but there is no longer thick mist. The thick mist is on the screen because this is the simulator and we simulate this thick mist. And as you can see, the captain is moving the vessel ahead, and the captain is rotating also the head left, right, up and down, like it is in reality. And the sensor, orientation sensor, shows the picture downside, how accurate, smooth is, and it is like in reality. And it is very natural to put the glasses to clean up all the hampered environment ahead of you. So we tested the whole system very in how to say, plenty of times till we are completely sure that we are absolutely safe to test the system in reality. I will show you the first picture. Practically, this is the first demonstration of the whole Iliad site, how we created different, you can see different in green, different sectors. We defined these different sectors in the harbor. And then we started to check the data which we received from Captain Todorov and his team to start training our mathematical model, which I believe Professor Ganchev will go deeper about that, because I'm not a programmer. Then after, we created this beautiful model. As you can see here, this is the raw data inside of the software, which is calculating, and practically I can say this software is educating himself from not himself. The correct is itself, because it is not a human being, but it's studying, it's evaluating, it is educating itself. And in the beginning, the software did it quite a big mistake in the prediction. But in time, as you can see on the next, the red one is the prediction, and the black one is the real data. As you can see, in time, the red is almost over the black one, which means that the software is very well educating itself. And after this education was done, we completed the application, and we gave that application to Captain Todorov and his team to test in real life. Now I will show you the movie which we did it during the real-time tests. So this is the vessel traffic tower, and this is the test vessel we used during the tests. You can see the ship is passing through the tower in beautiful weather. Of course, we have no chance to test the system into thick mist, but we tested the system in absolutely real life. So we have this transparent screen, as you can see on the picture, on the movie, and the transparent screen practically shows what the captain sees inside of the glasses. So this is what exactly he sees in the glasses. So now I'm with the glasses on my head, passing under the bridge, and as you can see here, the bridge is exactly in the position of the real bridge, where the real bridge is. So this is so according to the tests, I will show you one other movie. We can definitely say that the accuracy of the model we created is less than, I can say, less than 1 meter, which is more than enough. Say again? So you can see here on that picture where the actual buoy is and where is the augmented reality buoy. So this is one very good example how accurate is the system. So I will show you also in the continuous of this video Captain Todorov testing the system into the vessel traffic management system tower in real life. You can see all the beautiful monitors and how advanced is this vessel traffic tower, and all the colleagues there working hard to keep the safety on the highest level. Again, you can see some videos from the real use of the system, and I can definitely say that the system, even in this condition, is quite well developed, and the system can help all of us to improve the harbor safety to the highest level. I will show you, I will continue practically with the presentation. This is the actual highlight of the system, what you can see augmented reality in your glasses. And you can see here the ship course, ship speed, which is very important for the team on the bridge. And you can see the boundaries. Red one is your left side, green one is your right side, and practically you're inside of this boundary and you have to stay there. And this blue line is your best course. And when you see the blue line ahead of you, you're in the safe side. The photogrammetrical method we used to picture all the let's say buildings, the whole environment surrounding us is remarkable, because we can see even up to 1 meter below the water. So even we can see some rocks, as you can see from the screenshot here. And you can see how accurate is the picture. And when you see through your glasses, you have feeling that practically you see movie, but it's not movie, it is artificial environment we created. I already spoke about the port and starboard limits boundaries, and the good is that the team on the bridge, they have even sound which shows them when they are going to red or to the green boundary, in order to give them a word, keep them in a word during the whole safe passage. Some beautiful screenshots during the passage under the bridge. The captain and the whole team on the bridge, they have ability to show or to remove those boundaries, because sometimes too much information ahead of you or on the screen ahead of you is against you. So sometimes the captains, they prefer to have less information but vital information. So we have a lot of ship models inside of the model, in order to substitute almost every vessel which is entering the port with adequate ship model into the glasses. Here you can see that even we have graphical way to demonstrate exact course which is in front of you. So another feature we created here, in order to be connected with different partners inside the Iliad project, is that we have interface with different projects in Iliad, like Captain Todorov already mentioned about the current, which is very important for all of us working in the harbor. Second is jellyfish project, because when we receive data from that project for exact position of this jellyfish spill, we can visualize the spill inside of our glasses. Same is like oil spill. So the entire software is created with also in and out interface, which is very easy to be reached and to interface with third-party software and applications. As you can see here on this screenshot, you see the oil spill on the right side, jellyfish on your left side, and this is visualized practically in the vessels, and the captains, they can orientate in order not to go there, because this is not okay to go inside of the jellyfish spill or in oil spill. And on the end, I can say that we have, of course, done a lot, and we need to do a lot ahead. So this project has many phases ahead, and one of them is using the modern technologies like drones to land on vessel and to increase the navigational, how to say, the navigational accuracy even more. And even, as you can see on picture on position 4 and 5, we can land over the vessel drone cameras, in order the vessel control tower even to see what the bridge team is actually seeing and watching. And this will increase even more the safety. Of course, the drones can be used also for the inspections as well. So thank you very much for your attention. So I'm open to answer any questions, if such.
Thank you very much, Andrey. Absolutely impressive and fascinating what you can do with this automatic navigation. As I will repeat again to the audience that you are welcome to write comments and questions in the chat. And Andrey, you will stay with us, right? So you can participate also in the discussion when we arrive at that. Before we will move on swiftly. You were presented with the poll, and I will share with you the result. You were asked, what is the main challenge in port navigation? And you got four alternative, but that was fog, weather conditions, or traffic jam. And you see the winner is fog. So several of you are experiencing that as a challenge, I can tell. I just wanted to share this, very informal little poll with you. Okay. Thank you. We are moving on. And the next speaker is also from Varna. It is Todor Ganchev, and he is a professor of artificial intelligence at the Department of Computer Science and Engineering and also a founding head of the Artificial Intelligence Laboratory at the Technical University of Varna. Todor has been enthusiastically contributing to both of these digital twins in Varna. And well, actually, you were also a vice rector until recently, by the way, at the Technical University of Varna. So we are now going to listen to a very high-level expert in artificial intelligence. So Todor, the floor is yours.
Thank you. So I will just summarize what my colleagues explained, and we'll try to explain the big picture here. We have a digital twin of Varna Bay and the Varna Port complex, which made possible the two applications that were demonstrated already. And the main problem is that Varna Port is distributed infrastructure with more than 30 kilometers from the one side to the other side. From Varna East to Varna West, we have 15 terminals and some shipyards, and it is a huge territory with different topology and with different weather conditions. And the main challenge that we faced was how to improve the weather prediction, because current dynamic models that are offered has resolution of 10 by 10 kilometers or 5 by 5 kilometers, best of the best. But they do not really help for us because of the navigation channels of Varna Port complex and because of the infrastructure, which is in quite different places and with different weather conditions. So our first intention was to develop precise location-specific weather models that can predict with high accuracy and good resolution in time the weather conditions along the port facilities. And we started to working on that and achieved much more, as you can get impression from the presentations of Milen and Andrey. But what is important is that we developed the digital twin of Varna Bay, which is oriented towards safety improvement. We aim to improve safety in different ways. And then we also aim to increase the efficiency of the port operations, trying to reduce the number of days that the port remains closed due to fog or unfavorable weather conditions. So there is also one side effect that reducing the time ships stay on the rate also helps for the reducing the carbon dioxide emissions of ships. So we set several goals. At the end, I will summarize this. It is a joint undertaking. We actually developed this together, the Bulgarian Ports Infrastructure Company and the Technical University of Varna. With the active help of our stakeholders, we developed the technological framework we call Iliad Digital Twin of Varna Bay. And I would just mention few things of the distributed infrastructure and resources that are involved in this digital twin. We have simulation models which receive data in real time from 28 meteorological stations owned by Bulgarian Port Infrastructure Company, and also from 3 new sensors that were deployed by Tautech. These are the hydromast water current and level sensors that Captain Milen Todorov mentioned. And we have various data aggregation and application servers that run most of the code. And then we have machine learning modules that were developed at the Technical University of Varna. And these machine learning modules on the one side cover the meteorological parameters like wind, temperature, and humidity, and so on. We also have module for the hydrological parameters for the wind current and level. And we have modules for the vessel, for the different types of ships. And then we also have the navigation modules that were presented by Captain Andrey Stanev in the simulator. And we developed augmented reality and virtual reality modules of different objects. And the photogrammetric modules that were demonstrated also allow a very realistic representation of the physical world when we combine the augmented reality and the virtual reality. And we developed also various end-user interfaces for the different applications. What is important is that it is not one application that came out of the digital twin. In fact, in the Bulgarian Port Infrastructure Company, we deployed 3 different applications. One was the main risk assessment tool that were demonstrated by Captain Todorov, but we also have interface where the end users can, let's say, try to develop better modules of meteorological parameters, or trying to visualize the work of different modules and get the impression which is good, which is not good. We have instruments that help for improving this navigation and predictions. And since the longest maneuver in the Varna port is 3 to 4 hours, we focused on delivering modules for wind and wind speed and direction prediction up to 3 hours ahead, which is location specific with resolution 1 kilometer approximately, and then every 15 minutes up to 3 hours ahead. And beside the infrastructure that depends on sensors, we have also integrated citizen-reported observations through a web applications called ICC. And we have various other modules that constitute the digital twin of Varna Bay. Simplified architecture is shown on this slide. We have the, let's say, 4 basic layers. The first layer is the sensor layer, where we collect data from the sensor network, from meteorological stations, and also from the hydrological parameters. And also data from the citizen science, from the citizen reports. And then these are weather parameters, jellyfish congregations, pollution, and other reports that the people can really contribute. And then we have the information processing and information extraction level, where we filter and let's say recover data. If data are missing or if data are incorrect, we do some pre-processing steps in order to certify that the data entering the modules are really reliable and complete. And then we developed different modules using different technology. However, in the products that were demonstrated, we integrated not the most accurate modules, but those that are more reliable. And the regression module, for instance, that predicts the wind speed and direction, in 90% of the cases shows accuracy of, let's say, error is half meter per second of speed. I mean, only in 10% of the cases, error is more than 1 meter per second, which is, let's say, a good trade-off between speed and accuracy. There are more complex methods that we develop based on the deep neural networks and so on. However, they depend on external infrastructure, or they require too many computations. They are not really appropriate for real time. So our products that we developed are optimized for real time use on real servers. So, and then the application level are the different interfaces that you already saw. The desktop interface with the risk assessment, the glasses, and the transparent monitor for the pilots. What you see here is really a very basic description of our digital twin. But what is important to remember is that we have modules that are fed in real time with sensor data. And based on those modules, we are able to make predictions for the future, for the short-term, location-specific predictions of weather parameters with good resolution in time. So the end user using their interfaces can do their job safer or faster or better. This is the idea. I just want to mention a little bit more about the citizen reports, because this is a way to extend the coverage of sensor data. We have the meteorological stations, we have the other signals and the hydrological data, but having the citizens reporting provides extra dimension. Citizen can report some atypical events, or can report, let's say, congregation of jellyfish, or specific weather events at specific locations of the port, or pollution, falling objects. Sometimes a ship can lose a container, or I don't know, some other objects. These are things that are reported by the citizens. There is, let's say, software that summarizes reports and transmits the data into the digital twin. And from the digital twin, it goes into the applications of the virtual reality or in the risk assessment. And so far, we exposed two groups of citizens to our application. The one are, let's summarize as blue economy professionals. These are people working in companies involved with the port operations, the traffic managers and the pilots and the people who are experts. We consider their reports to be of high trust. And then we also have civil citizens, which are more naive. They do not have the special training for delivering high accuracy estimations of what is going, but they are everywhere. They are on the beach, they are around the coast, and then they can really provide valuable data. There were several cases of floating objects, buoys or whatever. So this information is quite important, and we consider it for the digital twin because it extends the coverage of the sensor data. And in general, we have a map that summarizes the citizen reports at different locations, and the reports can be viewed in a different way and by event with different filters. I will not go into details. This is on the marketplace, on the Iliad marketplace, and you can see this also operates on the site of Iliad partner Bulgarian Ports Infrastructure Company. You can reach the application, play, report. It is available also as open source to everybody who is interested to deploy it or to change it or improve it. So I will not go too much into the technicalities, but we'll mention that the blue boxes are infrastructure that we use from before the...
Todor, sorry to interrupt. I'm looking at the time. I think in interest of actually also having time to discuss, it would be good if you could speed up a little bit because we have three more. Well, we have one more pilot and then presentation, another one presentation. So if you could speed up, sorry.
Yeah, 1 minute to summarize.
Yes,
So
thank you.
I will not go into technicalities, but I would like to emphasize the impact of the digital twin we developed. And there are three categories. One is the technological impact. Actually, we tested a novel technology and evaluated this by the end users, which are real stakeholders. And then all the infrastructure established, resources, data, software modules will help build additional services, high-tech services, which are transferable. And the most natural thing is to transfer to other ports with whom we already have good collaboration in Burgas or in Crete. And then we have the economical impact of this technology because increasing the number of days the port remains open, or at least partially open, helps for the regional industry. This is the supply chains, but also enhances the revenues of the port operators and many other services that are related to the port. And we also have social impact because this technology contributes to sustainable development of the blue economy sector in the region and reducing the ecological footprints of shipping, improved competitiveness of regional industry, and the citizen science application that improves the engagement of citizens are impacts that we consider very important, and we are motivated to work beyond the end of Iliad project to enhance this technology and to deliver even bigger impacts. Thank you very much for your attention. Thank you.
Thank you so much, Todor, and sorry to shortcut you, but yeah, it was a very nice final note that you ended on. So thank you very much. In the interest of time, I think we just move on immediately now. And
can I say just sorry interrupting you, just one word?
Yes.
One sentence actually. We all created those applications in order to continue the projects, and all the applications are prepared, and we have methodological way how to import different ports inside of the application. So the applications are not closed. They are, like Professor Ganchev said, open source. So we can create any port all over the world. So that was the idea of making the digital twin prototype. So the prototype is ready. So now is the time to create the rest. So thank you.
Yeah, thank you, Andrey. And that's why I'd hope that we could, well, let's ask people if they can stay 5 more minutes over the planned meeting. So that would mean 4:35. And then I will kindly ask our next speakers to be as speedy as they can, so that we can actually manage to have a little bit of a discussion. It would be a pity not to actually be able to exchange a little bit of ideas and ask questions. So in interest of time then, I am going to introduce to you in one go 2 speakers, the 2 next speakers from Valenciaport. It's Aida Mora, and she's a researcher and also a specialist on innovation. So she is looking at this from market intelligence perspectives and looking and having more the business eye on the digital twin. Then Brandon Onuoha, he is the chemical engineer, an environmentalist, I would say. So they are, they have a good combo of expertise from the Port of Valencia. And here you go. I don't know which one will start the show.
Yes, I will start, Bente.
Yeah, thank you.
Thank you. Thank you for the presentation, and also thank you, Sofia, for inviting us, and also for the interesting presentations from Varna Port. Just really, really interesting. So we are very blessed to be here today, and we will share some insights on how digital strategies can help address the challenge of invasive species, with a focus on ballast water management at the Port Authority of Valencia. So before we dive into the specifics of the Iliad project, Iliad pilot, let me briefly introduce Fundación Valenciaport. We are a leading research and innovation center for the port logistics sector, and we are an initiative of the Port Authority of Valencia, jointly with other key maritime companies, universities, and institutions, to promote sustainability, digital transformation, and competitiveness. And within Iliad, we focus on data collection and simulation related to ballast water management, specifically addressing the spread of invasive species. So a little bit to put into context about the Port Authority of Valencia. We are commercially known as Valenciaport, and it manages 3 key ports along Spain's Mediterranean coast, Valencia, Sagunt, and Gandia, as you can see in the slide. Among these, the Port of Valencia stands out as Spain's leading Mediterranean hub for commercial traffic, especially containerized cargo. And with a strategic location and a strong connectivity to major international ports of the three ports managed by the Port Authority, we play a critical role in facilitating trade between Europe, the Mediterranean, and global markets, as you can see in the slide. And this extensive maritime traffic also highlights the importance of monitoring ballast water and the potential introduction of non-indigenous species. So given its hub status, vessels arriving from different regions bring ballast water from diverse ecosystems, which can introduce invasive species into local waters. And this is why our pilot includes a monitoring program with a particular focus on the Port of Sagunto, and later I will explain why the Port of Sagunto, where we are implementing an early warning system using environmental DNA. So a little bit of context about the ballast water. As maritime traffic continues to rise, we are witnessing an increase in incidents related to harmful aquatic organisms and pathogens in port areas, and these organisms are spread through ballast water that is a byproduct of maritime transport. So to address this issue, we are participating in a pilot that is assessing the risk of invasive species in the port of Sagunto using high-resolution geospatial data. This data is crucial for maritime safety, especially in coastal zones, where it can help ships prevent potential incidents involving invasive species. So also taking into mind that it's important to mention the International Maritime Organization's Ballast Water Convention, which sets the global standards for controlling the ballast water and to minimize the transfer of invasive species. The Port Authority of Valencia in this regard has been proactive in managing ballast water discharge, and the shipping companies are required to submit certificates detailing the ballast water procedures and treatment systems on board, and this ensures that ships entering the port have the necessary systems in place to comply with the IMO Convention. In that sense, the Port Authority, in collaboration with Capitania Marítima, closely monitors this compliance, and if there are suspicions of non-compliance, inspections are carried out on vessels. However, despite these efforts, challenges remain, such as the possibility for ships to deactivate their treatment systems. So, furthermore, periodic samplings of port waters are conducted to monitor the presence of invasive species in the port, in the 3 ports managed by the Port Authority. No risk have been identified so far, but this process continues to be a critical part of maintaining safe and sustainable port practices. So now about the pilot and why we selected the port of Sagunto. Firstly, because in the Odisea project, maybe some of you are familiar with this project, an invasive species analysis was previously conducted in the Port of Valencia, did not reveal any significant risk, but to avoid duplicating this analysis, we decided to focus on the Port of Sagunto, that as I already mentioned, is another port managed by the Port Authority of Valencia and another key port regarding traffic. As part of this initiative, Port of Sagunto is designated as the primary location for testing the Iliad ballast water pilot. And a comprehensive program for monitoring non-native species and ballast water, along with an early warning system using eDNA, is being implemented. So in order to develop this pilot, Fundación Valenciaport, in collaboration with Sparback and Ramani, we launched a subcontracting process in June 2024. And after evaluating the received proposals, the University of Alicante was selected as the most suitable option to carry out the work. So the monitoring program is structured in 2 phases. Phase 1, that is led by our by Sparback, involves an extensive literature review covering maritime traffic patterns, relevant regulations, high-risk non-indigenous species in the zone, and additionally, an early warning system is being designed. About phase 2, that is the one that Fundación Valenciaport is leading, we focus on field implementation, including a sampling campaign and some analysis. And this phase follows international guidelines such as the IMO Ballast Water Convention that I already mentioned, and also the Barcelona Convention. The work includes a sampling campaign, as I already said, and some reports on findings, and also a stakeholder webinar that we will make nearly on April, more or less, when we have the analysis of the results. So now I give the floor to my colleague Brandon in order to explain a little bit more about these 2 phases that we are carry on.
Hi, so thank you very much to my colleague Aida. So when we talk about environmental DNA, there are 3 key factors we have to bear in mind. The first key factor is collection of genetic material from water, sediment, plankton, and fallen organisms. As we all know, all these are found within the sea, and it is very much important to know what we're measuring at all times. The second key point, true. So, yeah. The second key point is the DNA extraction using a methodology named Kajin kits on PCR amplification of mitochondrial cytochrome oxidase subunit, which is actually called COI. This is a biological procedure that enables you to identify what's in the sea, making use of certain equipment, just to cut it short. Then the third one is the high throughput sequencing called Illumina MISEQ, bioinformatics processing. All these methodologies actually show that eDNA is a cutting-edge technology, okay, that enables us to identify these types of bodies within the sea. But obviously, all these has its advantages and disadvantages. Rather than disadvantages, let's just call them challenges. On the side of the advantages, we know that these are non-invasive, highly sensitive, and applicable to a broad range of species. That's to say that just making use of a string of eDNA, you can now identify a whole body of work within the body of the sea. And on the other hand, we also know that this allows us to detect on an early stage the invasive species before it establishes as a lab population, just with a string of DNA or with a very low concentration of it. We can identify what's there in order for us to avoid for it to get bigger. So in terms of the challenges, all this obviously is related to regulatory compliance, contamination risk, and we also have to bear in mind the cost considerations. Due to the fact that it's in an early stage, some regulatory compliance and also the cost considerations are two key factors due to the fact that it hasn't been deeply investigated as it ought to be by this point. But we hopefully and we believe that in the near future, we'll have much more information regarding to this. So moving on to the next point. As my colleague said, we're on an application stage at the port of Sagunto. And on this stage, we've already done all these methodologies, we've already carried it out. And right now we're in the stage where we're processing this information. So by the time this information gets back to us, and the webinar that she mentioned that will be between April and May, we'll now present these results. And of course, hopefully, there won't be any invasive species present. So now, in such webinar, apart from presenting these results, we'll also present the guidelines, or we'll prepare a guideline that will teach all the ports to understand how to make fun of the invasive species the moment that they detect it. Okay, so being this said, we now know that the Port of Valencia is prepared to tackle this type of event. And through that knowledge that we now have in this webinar, we'll now show how to tackle it in other ports. Of course, bearing in mind that each and every single port has a different type of parameters and characteristics, but that's what the guidelines for. So thank you very much for your attention.
Thank you so much for you for being, well, first of all, giving us a very interesting introduction to your digital twin. Absolutely very high importance on that. And thank you for being on time. And we have also a poll. I will share the results while I'm introducing the next speaker. Can you stop the sharing, Brandon and Aida? Yes, thank you very much. So moving on very quickly, Noemi, thank you for your patience. So Noemi Mene, she works at the International Association for Cities and Ports, and she's been particularly interested in in navigation and sustainable mobility in these cities and ports. So with that, Noemi, can you, I give you the floor and we will move on. Thank you very much.
Thank you, Bente. We'll share my screen now. Okay. Hope you can see it soon. So yeah, just very briefly, as given that I don't have so much time to keep going. So very nice to meet you. Thank you so much for inviting me to speak on this matter. So I'm Noemi Mene. I work for AIVP. So very briefly, as a presentation of the organization, as some of you may know, but some of you may not. We're international organization that brings 190 members that are both port authorities and local authorities, but also some professional organization. We have 50 countries represented. And we really want to organize a dialogue between cities and ports on a lot of different matters. Actually, some of the speakers of today are maybe they don't know about it, but they are part of the network. Bulgarian Ports Infrastructure is actually one of our members. We were supposed to have Oslo Port in the webinar, and they're also part of AIVP. So we are representing the dialogue based on our work that we call the Agenda 2030, that is based on the UN SDGs that was launched in 2018 on a range of different topics. So we have sustainable mobility, energy transition, port culture, health and life quality. So all of this is actually very relevant to when we speak about digital twins. As you may have heard during this webinar, we could see that the digital twins are actually can have a lot of different applications. So we saw that it could be on energy transition, it can be also on safety, it can also be on biodiversity and protecting the nature here. So what I'm going to do is just present 2 examples of what is being done in our network by other members of our network. So one is the Port of Bordeaux and the other one is the Port of Barcelona. So very briefly, one of them, so the Port of Bordeaux has developed their own digital twin of the river. So they're very specifically is on really hydrological and meteorological data. So it's not about port safety, it's really more on predicting what the river will look like according to weather events, according to extreme weather events as well, and predicting the climate change. So it's been developed by the Port of Bordeaux that's being located upstream of the river, well, a little bit upstream of the river, to see exactly what they will have to do as dredging, for example. So it's a collaborative tool that they've been developed with a lot of local partners. And it's quite interesting because it's all open source, of course, and it's being open to, and it's open data, so it's available for a lot of outsiders as well. And then we have the Port of Barcelona that developed their own digital twin within the Pioneers European project, and for themselves is calculating the emissions of the ships in the port. So it's kind of a different use of the tool. What is interesting in Barcelona is that they also had the development of a digital twin for the city, for the local authority on a different aspect that is more related to the planning of the city, related to mobility, health, and accessibility. But maybe we could envision at some point some kind of merging that could be within the 2 digital tools. We could see a lot of different application actually of what could be done. Then I also wanted to present a little bit the Magpie project. We're involved in the Magpie project. We're one of the dissemination partners. And it's also Horizon 2020. It's also financed by the Green Deal. The idea is really to promote the decarbonization of the port, but also of what goes on around the port, so also coming and going from the port. And within this, one of the work packages is on developing a digital twin. That is on several different matters. The idea is at the end to have like a proper, how to say, a dashboard that covers a lot of different aspects of the digital twin. So with a greenhouse gas tool and energy matching tool, the ports that are developing are Rotterdam, Haropa in France, Sines in Portugal, and Deltaport in Germany. What I'm not going to enter in the detail of all of this. What I kind of wanted to explain is also our position of the organization is what are the key issues and the key topics around the digital twins. I think that's why I've been invited to the discussion is so what we've seen in the network is mainly the difficulty of data gathering. We've seen it in the Magpie project, for example, where the port of Sines in Portugal is the owner of the port and it's the landlord, but it's also the terminal operator. So they can actually provide the data themselves, which is really useful. And for example, Rotterdam is actually only the landlord. So they have to rely on other stakeholders to bring the data, which has been very complicated then to set up the digital twin for them. So we've seen the difficulty of the data gathering. We've also seen the problem with the ownership of the data afterwards. Once you've set up the digital twin, for example, in Bordeaux, is now who has access to the data and what is the data going to be used for. So once you have the data open, who's going to make decision with that and how, because it's open, so you can observe it and you can analyze it a bit how you want sometimes. So it's also a question of how it's going to be received and analyzed. It's also of who is going to pay for the process of setting up the data. So for example, in the Magpie project is a lot based on the European funding, but what comes after the end of the European funding, what's going to happen then of the maintenance, of the update of the data. For example, in Bordeaux, we've seen that it's now a set of volunteers that keep on bringing the data and maintaining the website. But if at some point the volunteers are not volunteering anymore, so what happens then? So it's also a question of maintenance and keep on going with the work. We've also seen that another big problem that we've seen, and it's also a problem for the cities, and that's why AIVP comes into play as well. It could be that the storage of the data, actually, when you set up such a big tool and you need to collect so many data, like where do you actually store it? I know in Bordeaux, for example, they had to study where they're going to store the data in a way that is energy efficient, because you want to save energy when you're setting up a tool like this. But if you're creating even more energy use by storing all of this data, then it doesn't make so much sense, right? So there's also this kind of questions. I know in Barcelona, they have their own center for computational activities, so they're doing it locally, but I know that's also one type of problem that can be used. What we also see is there's so we've seen so many applications of a digital twin, but we can even foresee more. So it could also be, we work a lot on cruises and the impact of cruises activity on the city. It could also be something related to predicting congestion and predicting ways and flows of people and traffic coming in and out of the port. That's one of the tool for the Magpie project, but we can also see it in other aspects. We're also involved in another project on urban and climate resilience to extreme weather events. So it could also be used to predict what is going to happen with climate change on port infrastructure. So many different types of application that we can see. It's still, I mean, we could talk about it for another 2 hours, but I think I will stop now. Please don't hesitate. I will type my email in the chat, so don't hesitate to reach out to me for more information and discussion. Thank you so much for inviting us.
Thank you so much, Noemi. And now we are way over the time, and I'm starting to get nervous about my plane. Anyways, it has been very interesting, and I don't see that we have any questions in the chat, and some has had to go. But what I suggest, goes to Varna and to also you, to Noemi, and I believe actually the Valenciaport had to leave already, but I see a possibility to go straight to a discussion. As Andrey was saying, they are interested in discussing how what they have developed can be transported and used elsewhere. And you, Noemi, now are saying that you are working on these issues. So obviously you are representing an interest association. And I know I've also seen ESPO participating, attending this, and they didn't have time to prepare for this. But I foresee that we could meet again in a quick fix presentations of the facilities we've heard more about today, but very quickly, and then focus on having a dialogue, a discussion, to really set time off to do that. So that will be my suggestion for follow-up. So thank you, all of you, so much for your presentations and your contributions, and we will be happy to follow up. Sophia and we will follow up with a suggestion for a new webinar where we are focusing on discussing. Now that we know about each other, I think we have a good starting point for a follow-up. Yes.
Thank you so much. Goodbye.
Bye-bye. Until.
Thank you.
And thank you all. We have had so many, Egypt, Canada, so the representation of the audience has been very wide. So hoping to see you again. Thank you.
Bye-bye.
Thank you. Bye.
Bye.